Hey, this is Sean with Alexander Tutoring, and today we are going to talk about logarithms, a very important topic in pre-calculus that can be pretty confusing because it's hard to understand what they really are. So what is a logarithm? Well, it's the inverse or function of an exponential. So here's an exponential. 10 to the x equals 100. What does x equal? Well, just from looking at it, you could probably figure out that x equals 2 is the solution, right? So in other words, a 2 goes into this function, and a 100 comes out. So what's an inverse function? Well, basically it flips the input and output. So what it should do is have 100 go in and have a 2 come out. And what that looks like is log base 10 of 100 equals 2. In other words, when a 100 goes into the logarithm function, a 2 comes out. Now, I understand that this could be confusing. This is probably unfamiliar, but the logarithm is a function. That's like f of x. It could be f of x, g of x, log of x. So let's get more into logarithms, because where do these come from? Well, back in the day, before calculators, how did they do logarithms? Well, they literally were a table of values you had to look up in a book. So let's pretend we don't know anything about logarithms just to understand where they come from a little better. So I'm going to write down a few equations for you. Let's say we had the 10 to the power of x equals 1. And I said, what does x equal? And just guess and check. We're just going to guess and check. Well, in this case, maybe you know that anything to the power of 0 is 1. So in this case, x equals 0 is the solution to that equation. Okay? What about 10 to the x equals 2? That I don't know, but I'm going to use my calculator just to take a guess. Well, if x was 1, that's too high, right? Because 10 to the 1 is 10. So it's got to be less. It's got to be a decimal. So let's try like 10 to the power of, let's say, 0.2. That's a little less than 2, 10 to the power of 0.3. That's pretty close. So x is approximately equal to 0.3. In other words, 10 to the power of 0.3 is 2. Okay, let's do another one. 10 to the x equals 3. What does x have to equal? Again, we're going to guess. It's probably going to be bigger than 0.3, but less than 1. So let's try 10 to the power of 0.5. It's 3.16, so a little too high. 10 to the power of 0.45, a little too low. So right about, okay? And again, I'm just finding these by guess and check. So these are the solution sets. Now, so just looking at here, 0 goes in, 1 comes out. That's for our first one. 0.3 goes in, 2 comes out. 0.48 goes in, 3 comes out. These are the points on the exponential. And so what the logarithm should do is flip these, right? It should be the inverse function. In other words, what we're looking for, we'll say 10 to the x equals y, is a function that does the following. I want to find a function that if I plug the left-hand side into this function, I don't even know what the function is, I'm just calling it fn. So I'm plugging the left-hand side of the equation in, and I'm plugging the right-hand side in. What I want this function to do is deliver me the x. So basically I want this left-hand side to turn into x equals some function like that. That's what I want this function to do. Okay, well, what the heck is this? Let's dig a little bit deeper. Now, keep in mind, we already found these x values up here. Okay, so whatever this function is, we know that when a 1 goes in, because we're flipping these values, remember it's the inverse function, we know that when a 1 goes in, a 0 comes out. So whatever our inverse function is, we know that when a 1 goes in, a 0 comes out. We know that when a 2 goes in, a 0.3 comes out. Again, inverse functions reverse the x and y. Hopefully you've seen that. And for the last one here, we know that when a 3 goes in, a 0.48 comes out. Again, we're trying to find the inverse function of 10 to the x equals y. And what we're basically doing is creating this function that we don't know yet is the log base 10 function. So let's see what these points look like on a graph real quick. Okay, 1, 2, 3. And on the y-axis, I'm going to make the y-axis small. I'm going to make these 0.1, 0.2, 0.3. Okay, let's graph these points. I'll switch colors here. So we know that when a 1 goes in, a 0 comes out. That's a point right here. We know that when a 2 goes in, a 0.3 comes out. That's a point right here. We know when a 3 goes in, a 0.48 comes out. That's probably like up here somewhere. And we could continue this progress using a guess and check. Again, I was just solving these equations. 10 to the x equals 1, guess and check. X was 0, solves it. 10 to the x equals 2, guess and check. 0.3 solves it. If we continue this process, we'd get something that looks like this. And that is your logarithm base 10 function. Okay, this function that we've created is what log base 10 is. Okay, so we've basically put it together through guess and check. Let's see it this way. So log base 10 of x is the inverse function of 10 to the x equals y. Excuse me, I made a little mistake here. That x shouldn't be there. Y equals log base 10 of x. Okay, those guys are inverse functions. That's what the logarithm really is. So just so you can see how it works in practicality, if you have a problem like 10 to the x equals 5, what you can do is take the log base 10 of both sides of the equation, okay, what does the left-hand side equal? Well, remember, we forced this function such that the left-hand side equals x. So in general with logarithms, when the base of the logarithm, 10, matches this guy, it delivers you the exponent, in this case x. And what is the log base 10 of 5? Again, you can use your calculator for that. Think of it as like a table of values in your calculator. So log base 10 of 5 is roughly almost 0.7. So again, it's easy to get lost. What is the meaning of this? What is the log base 10? What is this 0.7? It's the power to which you raise 10 to get 5. Okay, I hope that helps you understand what a logarithm is. It's a function. It's a function, the inverse function of an exponential. Okay, I hope that helps. Have a great day. Take care.